Hello again. So, sawmilling. This time we go through the introduction to the kilning module, which is on pages 130 to 142. Tällä kertaa myös sitten huomaatte, että tässä on sinisellä myös summattuna suomenkieliset pääkohdat. Me on sovittu, että me tehdään näihin introihin tämä, mutta kokeet tulee olemaan edelleenkin englannin kielellä ja sitten luennot valtaosin englannin kielellä, mutta tämä jonkin verran tulee helpottamaan teidän elämää. Okay, so first of all, revise again the previous modules and why and how the kilning module and the process is linked to the other parts of the process. For instance, the production planner, our old friend, he needs to know what is going to be specially kiln dried against orders. Usually, you don't specially kiln dry unless you have a specific order for that. Read also the handbook pages between 130 to 104, titled "Drying Timber." This is important that you have like a good basics, especially when we have the guest lecturer with us after the first session. I will be speaking more about the kilning's role in the value chain, including references to the timber grading, and then the Valutech lecturer concentrates more on the technical side of the kilning and the processes. So what is kilning? Moisture content of the timber and how is it expressed? That is what it's all about. That is the measurement of the moisture content. So in short, it is the mass of water in timber expressed as a percentage of the mass. There are in the book clearer explanations on how it's being measured. What is important to remember that moisture content is not a static absolute value which remains always the same once the goods have been kilned, because it changes with the humidity in the air. For instance, inside versus outside, winter, summer, and Finland and tropical countries. As an example, in Finland, when we have the heating on more in the winter time, then the timber used inside in the paneling and in furniture tends to shrink. If you have tongue and groove paneling, that tends to shrink, and if it has not been pre-painted, you will see little stripes over there. And then conversely, when the heating is taken off and the humidity in the room increases, then the pieces of timber expand. We also have to understand the difference between air drying and kilning. Air drying is the traditional method in the old days, so that pieces were individually stacked in between sticks, and then they were manually then taken out. With the increases and improvements in the sawing process, we actually got the artificial kilning, and that is basically a process whereby you speed up the taking out of the moisture out of the piece of timber. It's also very important to remember in future life, in many practical instances, you will come across this one, that moisture content also varies within a piece. So, for instance, if you take the reading of the moisture content, so you really can't use the surface treatment measurement, and inside is sort of quite different. So usually when you take the measurement, you put, if you have the moisture meter, the prongs, the little needles, deeper into the piece. So why is timber then dried or kilned, as the term goes? Well, if the timber is not kilned, so most of all, I think the most important thing to remember that we are improving the wood's properties for the intended use. We are obviously also speeding up the process, because in the old days, the timber could have been air dried over the winter. And now we are talking about a period usually between sort of 3 to 4 days maybe. So you are generally improving the properties of the timber as well. you take the bending properties that changes uh, uh, changes with the kilning, and also the strength. Usually, if you kiln dry the piece of timber, it gets stronger. If you don't kiln the piece of timber, it will mold. If you leave it for instance against the ground in soil contact, or with water, so in the end you will start the rotting process as well. There is the discoloration which you might end up getting. That is something which happens a lot more easily late spring, early summer. But also it's important that timber is usually easier to work with when it's being kiln dried. There's one exception: thermally modified timber, heat treated timber. Actually, it gets so strong that, for instance, if you want to put a drill into it, so you need to drill the hole first before you put screw in there. Other advantages, well, gluing. Usually the glue manufacturers say that they guarantee the glue line only if the pieces of timber are maximum 16%. And remember, the shipping dry is 18 to 20. It's also important for the transportation because dried wood is lighter, which means that there's less fuel being used during the transportation. Also, with the end use product, especially when we talk about panel products, for instance, uh, plywood is being used for horse boxes, trailers, and such, because it's got good sort of properties, sort of weight to strength properties compared with metal, for instance. So bear that in mind. Also, dried wood, remember, it shrinks about 4% when it's taken to shipping dry. So if you have these big conventional shipments, so 4% out of thousands of cubic meters actually means that you can ship more cubic meters within the same ship's space. You better learn also about the drying methods. These will be tackled now mainly during the guest lecture, but I would like you to learn beforehand some basic concepts and terms, so it will be a lot easier to follow, and it's also very important, obviously, for the exam later on. But sort of make yourself acquainted with chamber kiln, how that is being filled and how it's being emptied. Understand what a progressive kiln is, and the same things like how does it compare with chamber kilns, how is it different. Kilning automation, why is it important? Kilning schedules, why are those important? So, like I said, those will be sort of tackled during the guest lecture to the detail. Then let's talk about drying defects. Drying is and kilning is actually a very part of the sawmilling process, and that is a part of the process where you can actually do a lot of damage to the timber. And we just go through, the most typical ones, what might happen there. First of all, checks and splits, which are also called shakes. Um, Usually it's a visible problem, but sometimes, these smaller checks are more difficult to detect. They might, for instance, only, become visible when the end product, like door, is being taken inside, and the air humidity, uh, goes down, and it sort of expands the shake. Usually, shakes and splits are caused by kilning, but it can also happen, in the forest, when the trees are felled. For instance, you have a big tree, you are in midwinter, it's more brittle, and you fell the tree, so when it sort of hits the ground, so there could be damage to the fibers. It can also happen after the kilning process, when the goods are being handled, when, for instance, in the packaging plant, the pieces are being dropped before they are to the conveyor, before they are being packaged. This is especially for wider sections, and especially wide sections in relation to thickness. So thin section with lots of width is the most prone one to be shaken. But as a rule, the basic reason for the kilning shakes is usually too quick and wrong type of kilning. There are also reasons, which have an effect on the kilning result. The grain direction of the timber, variation in the starting level of the moisture content in the raw material in summertime or springtime. Some logs may have been sort of waiting in stock for a few weeks, and then you get fresh logs. So the starting moisture content of those is different, and then you just sort of play with the averages in the kilning process. So that might be causing some issues. Sawing patterns, remember, if you take out the heart, so then you get less shake in the timber. And then like proportion of hardwood and so on and so forth. Read those in the book. Then we might also be getting end splitting. Usually, as you understand, the pieces they dry faster in the ends than they would dry in the middle. But usually, these little and short end shakes are being trimmed in the final grading before the packaging. And they are usually only a few centimeters long. So this is now the reason why when we want to have a 4.2-meter long piece of sawn timber, so the log is 10 centimeters longer, so that this allows for the final trimming and taking out the end shake of the piece. There might be also hard checks, which might happen already, when the tree grows. Not so often, but a possibility. Then there are surface checks, and that's caused by tension stress. There are internal checks, but these are more common in hardwoods. When we talk about softwoods, that's not that much of an issue. Then there might be knot checks, which again, would be used by the wrong type of kilning. And also, if you compare redwood with whitewood, so you can actually tell the kiln dried whitewood spruce from redwood pine by looking at the knots, because usually in kiln drying, the whitewood knots tend to check. There's a little shake, or actually it's a cross-like shake. So that can easily sort of tell you, if you don't know otherwise, which species you are talking about. Then there are, of course, also like these micro checks like we have been talking before, and they might be caused by, too quick drying or too fast cooling. In the wintertime, once the goods are coming out of the kilns, the temperature is still a lot higher than in the outside temperature. If you let it cool very quickly, so that again, might cause some shakes to the surface. If we then carry on to case hardening, it means that the top part of the piece is actually harder. So that will be causing most probably more shakes. Then with the kilning, twisting. So the old song "Twist and Shake." Remember that's not the kilning manager's or kilning foreman's favorite song. Twisting can happen because of the variation within the piece, also by the bad stacking, and the pieces when they are in the kilns, they have sort of room and possibility to move and live. So that's one cause for the twisting. And then also we know that the lower down we take the moisture content, the more the pieces tend to twist. So if you have a piece of timber which you have cut straight from the tree and you haven't kilned it, so that is definitely going to be a straighter piece than the one which is being kilned to ship in dry. And then if you have specially kiln dried goods, they tend to be twisted even more. Cupping is also typical for timber. It's not actually a defect. It is just something that happens with it. But again, that's all about the shrink to do with shrinking and tensions. You will learn that when we talk about wood technology. And again, remember, you have cupping, especially with wide sections which are thin. they tend to cup the most. Then drying defects, discoloration. There are chemical changes in wood, so if you do it wrongly in the kilns, you might actually cause discoloration, blue stain to it, but also fungi will have an effect on the pieces. So that's part of the discoloration as well. Furthermore, and this is now especially with pine, redwood, you have the resin flow. If the temperatures are high, then the resin starts to flow. For instance, you are in the sauna and you have pine paneling out there. So you will notice that in the high temperatures, the resin will start flowing from the knots. And also, if it is very resinous timber, also from other parts of it. Then finally, we talk about the kilning and the energy. Um, Kilning is naturally a major cost in the sawing process. Um, Heat energy is needed, and normally one needs about sort of for 1 cubic meter of wood, about 200 to 400 kilowatt hours of heat energy. So as you understand, it's a cost. I mean, whether you use it for 5 cents or what, but you see that it is a cost. So therefore, if the moisture content needs to be taken below the shipping dry, there is definitely an increase in the production cost. And also we have to now remember that if we take the moisture below the normal shipping dry, then also the shake, twist, and cupping comes more into the picture. So when costing the especially kiln dried goods, so one has to take into account both the actual cost of drying and also the increase in the defects which you need to downgrade. Actually, then not heat energy, but the electricity is required mainly for the air circulation or fans. But what is also positive is that mills are usually self-sufficient with their heat energy requirements. We have been talking about how the byproducts are important for the process and everything is being used. So as a part of that, so the bark is being burned, part of the sawdust as well, and that then generates at the mills heat, mainly heat energy, and also that heat energy could also be sold to the neighboring municipalities. So this is really the summary of the kilning part of the book. Thank you.